Hello. Yes! And welcome to our Objective 1.5 notes. Objective 1.5 says I can find the inverse of a linear function algebraically. Now to get started, let's talk about what an inverse means. The inverse you are probably most familiar with is the operational inverse. Now the operational inverse you're taught actually from a very young age. The operational inverse is how we undo operations. So think about addition is probably the first operation you learned. How do we undo addition? We undo that with subtraction. Those are operational inverses. To undo adding 3, you subtract 3. Multiplication is another inverse with division. All right, to undo multiplying, you use division. Those are operational inverses. In terms of functions, though, there's another way to think about it. Think about it as that machine where I put in x to the function f of x and I get out y, my output. I plug in an input, I get out an output. The inverse of this would be to switch the order where I start with my output, I plug it in to the inverse function, that -1 right there represents inverse, and I get out the input, okay? That is what the inverse means here, where I'm plugging in a different value into the inverse function to see what my original value would have been. Okay, so let's talk about how we can do that with our linear functions. So to algebraically find the inverse of a function, the first thing we're going to do is we're going to replace f of x with y. And the reason we do that is just so it's easier to write. So over here on our sample problem, what was y we will now say is f of x, or what was f of x we will now say is y, -2x plus 5. And then we are going to switch the x and the y in our equation. And the reason we're doing this is because, think about here, we had our input that we were plugging in to get an output. We're switching that. Now we're plugging in the output to get an input. So we're actually going to rewrite this as x equals -2y plus 5. And now we're going to solve for our new y, which was previously x. So to solve here, I would subtract 5, x minus 5 equals -2y, divide by -2, and I would say that y equals -1/2 x plus 5/2. And the final thing I'm going to do is I'm going to rewrite y with f inverse of x to show that inverse relation. So my final answer here would be f inverse of x equals -1/2 x plus 5/2. And that would be my final answer there. Okay, so let's do a couple examples together, see how we're doing. So let's start here with letter A. So first thing, replace f of x with y. So y equals 4x minus 5. Switch x and y, that's the key. That's the essential component because that's what's performing the inverse here. Now solve for y. So I'm going to add 5. So I'll have x plus 5 equals 4y. Divide by 4. So I'd have y equals 1/4 x plus 5/4. And my final, rewrite it as the inverse of f of x, so 1/4 x plus 5/4. Now another instruction I want you to do is go ahead and graph both the original function and the inverse on the coordinate plane. So with this original function, 4x minus 5, I'd have a y-intercept of -5. I'd go up 4, right 1, up 4, right 1, up 4, right 1, down 4, left 1. Beautiful. And I can graph that. That would be my original function. Now let's also graph the inverse function, -1/4 x plus 5/4. So 5/4 is going to be here, a little tougher, but I will go up 1, right 4, up 1, right 4, down 1, left 4, down 1, left 4. And go ahead and connect my dots this way. Excellent. All right. And that is both the original function and the inverse graphed on the same plane. All right. Let's go ahead now and look at 5/3 x plus 3, letter B here. So, first step. Oh, sorry. I didn't actually write my final answer down here. f inverse of x equals 1/4 x plus 5/4. Had the blank for it, I just forgot to write it there. There we go. Okay, let's try letter B now. So first step, switch f of x to y, so 5/3 x plus 3. Switch x and y, so x will be 5/3 y plus 3. And then solve for y. So I can subtract 3, so I'll have x minus 3 equals 5/3 of y. I will then multiply both sides by 3 to get rid of that denominator, so I'll have 3x minus 9 equals 5y. Divide by 5, and I get y equals 3/5 x minus 9/5. So the inverse function, f inverse of x equals 3/5 of x minus 9/5. Fantastic. Okay, let's graph both of these. So y, 5/3 x plus 3. So from there I'd go up 5 and right 3, or down 5 and left 3, down 5 and left 3. See, that'd put me right there, wouldn't it? Go ahead and connect these dots. There we go. Okay, now let's try to graph our inverse function, 3/5 x minus 9/5. So 9/5 was just a little more than -2. And I'd go up 3 and right 5. That'd put me right there. Up 3 and right 5. Put me right there. Down 3, left 5. So 1, 2, 3, 5 over. Okay, down 3, left 5. Put me right there. Go ahead and connect these dots to the best that we can, at least. There we go. All right, and here we have it. So the reason I had you graph is because there's something that's really cool that happens between a function and its inverse. And you might notice it, you might not. A function and its inverse actually have some symmetry. Now we've talked about symmetric to the y-axis with even functions and symmetric to the origin. That's not the case here. In fact, it's a different symmetry. It's symmetric to the line y equals x. And if you can see it here, this line of symmetry, y equals x, is appropriate because what are we doing in the function? We're switching x and y. So it makes sense that that line is symmetric to y equals x, and that's a super easy way to check to make sure that you're doing it well. If your answers aren't symmetric to the line y equals x, we either graphed it wrong or we have the wrong function. So that's a great way to check. All right, well that's inverses all for these linear functions. So hopefully we're feeling good with objective 1.5. If you want a little more work on this, go ahead and check out that sample problems video. If you're feeling confident, go ahead and dive into the practice problems. This is Mr. Carter signing off. I'll see you next time.